All right, let's jump right in. Welcome to The Explainer. Today, we're unpacking some massive ideas from Energy for Circular Economy, Book 1, Session 2. Our goal here? To fundamentally flip how you look at the physical stuff surrounding you by shifting our mindset from a linear economy to a circular one. So let's kick this off with a question. Think about the smartphone you might be holding right now. What actually happens to all the massive energy used to mine the metals, build the microchips, and ship it across the globe when you finally toss it out? Well, in a linear system, it's just gone, lost forever. You see, every single product is basically a giant invisible energy battery. It holds what we call embodied energy, which is all the energy poured into it during production. When products get trashed early, 100% of that embedded energy simply vanishes into a landfill. So, how do we plug this massive energy leak? We have to zoom way, way in, right down to the drafting table. Enter eco-design. This is all about baking environmental and sustainability considerations into a product from the absolute earliest stages of development. Because honestly, a product's fate, whether it ends up as a total logistics dead end or a highly recyclable asset, is pretty much sealed before it ever hits the factory floor. And the sheer scale of that early decision-making is mind-blowing. It's estimated that nearly 80% of a product's environmental impact is locked in during this exact design stage. 80%. Just think about that. If a designer decides to use a permanent adhesive instead of a couple of simple screws, they've literally just dictated how much energy it'll take to break that product down years later. Which brings us to a major showdown: standard design versus design for logistics, or DFL. Usually, standard design is all about aesthetics and how fast we can slap something together on the assembly line, which means lots of permanent gluing and welding. But DFL plays the long game. It uses modular, snap-fit components and standardized parts. Not only does this let you pack parts super densely for cheap, efficient shipping up front, but it also makes taking it apart down the road incredibly cheap and highly energy efficient. Okay, so once a smartly designed product is actually in our hands, the whole game is about keeping it there. We do this through 4 main product life extension strategies: direct reuse, maintenance and repair, upgrading, and remanufacturing. Basically, for every extra year you keep a product alive, you are stretching out its original energy investment over a longer timeline. You're effectively dodging the massive energy hit required to dig up new raw materials and build a brand new replacement. Now, this highlights a critical piece of the puzzle: the circular hierarchy. We've been told for decades to recycle, right? But in a true circular economy, direct reuse is the holy grail. Why? Because reuse takes almost zero extra processing. It totally preserves that embodied energy we talked about. Recycling, while obviously way better than throwing something away, still demands a serious chunk of energy to collect, melt down, and remake those materials into something new. But here's the catch. To extend a product's life, we eventually have to get it back from the consumer. So let's zoom out a bit to the meso level of the supply chain and look at the reverse logistics challenge. Pushing products out to customers is only half the battle. If we want to capture that embodied energy, we've got to figure out how to pull those products back. And it is a night and day difference. Forward logistics is a dream. It's predictable, uniform, perfectly boxed items going from one factory to a few stores. Reverse logistics? It's total chaos. You are trying to hunt down used, unboxed, and sometimes broken goods from 1,000 different random households and intelligently route them all back to a central hub. To see how we actually wrangle this chaos, you have to look at the pathways involved. It's not a straight line at all. It's a complex, wildly divergent route a product takes once it comes back. Every single returned item has to be caught, inspected, and then dynamically routed to squeeze out its absolute maximum remaining value. Supply chains tame this beast using the 5 R's of reverse logistics. First, returns, just putting an unused item right back on the shelf. Second, resell, routing it to a secondary market. Third, repair, fixing a broken component so it can keep going. Fourth, replace, sending the customer a fresh item while the old one gets analyzed. And finally, recycle, breaking it down to raw materials. Notice how every step down that list chips away a little more of that original embodied energy. Now look, we have to be realistic here. Moving things backward does take energy. That's the energy penalty of collection and transport. But, and this is a big but, that penalty is blown out of the water by the circular save. For instance, taking back and remanufacturing a heavy automotive engine uses 50% to 80% less energy than mining the raw materials and building a new one from scratch. The energy math is just a massive win for closing the loop. To actually make these reverse loops financially viable, our business models themselves need an upgrade. Enter the functional economy. This completely shifts the mindset from selling you a physical product to providing you with a service. Think car sharing instead of owning a car, or buying lighting services instead of a bunch of light bulbs. When the manufacturer retains ownership of the product, you better believe they are suddenly super incentivized to make it insanely durable, easy to fix, and highly energy efficient. All right, zooming out even further to the macro-level ecosystem, we find industrial symbiosis. This is where industries buddy up and literally mimic a natural ecosystem. In nature, waste doesn't exist. One organism's trash is another's dinner. Industrial symbiosis applies this right to factories. One plant's waste, byproducts, or excess energy become the literal raw materials for the guy next door. The payoffs here are huge: shared materials, shared water, and drastically reduced transport energy. There's an amazing real-world example of this in the industrial park of Kalundborg, Denmark. There, a power plant generates all this excess waste heat. Instead of just venting it into the sky, they capture it and pipe it right over to provide heating and processing energy for neighboring factories. It is a brilliant optimization of system energy. So how on earth do we visualize all these micro, meso, and macro strategies working together in harmony? For that, we turn to the grand unification model of the circular economy, created by the Ellen MacArthur Foundation. It's known simply as the butterfly diagram. This diagram is gorgeous in its simplicity. It cleanly splits all the materials in our world into two continuous, totally distinct loops, making up the two wings of a butterfly. This visual is absolutely critical because it maps out exactly how we need to manage different types of resources to stop the bleeding and retain all that embedded energy. Let's check out the left wing first, the biological cycle. This side is for your biodegradable consumables, stuff like food, agricultural waste, or natural cotton. These are materials that can safely rot and return to the earth. The entire goal of this wing is regeneration, using natural processes like composting or anaerobic digestion to gracefully hand those nutrients back to the soil so we can grow tomorrow's resources. Then, over on the right wing, we have the technical cycle. This is the home for non-biodegradable durables. Metals, hard plastics, synthetic chemicals, they can't go back to nature, so they are trapped in this wing, forever circulating. Now look closely at the loops here. The tightest, innermost loops, sharing, maintaining, reusing, those are the absolute top priority because they preserve the product and its energy. The widest outermost loop, that's recycling. It's our absolute last resort because it eats up the most energy to pull off. Which brings us to our final thought. Take a second right now. Literally, look at the objects on your desk or just around the room. Your computer, your coffee cup. Are they designed for the biological cycle to feed the earth? Are they built for the technical cycle to be endlessly repaired and looped? Or is all of that precious embodied energy currently on a one-way ticket to a permanent landfill? Once you realize that energy is the true currency of the circular economy, it completely changes how you see the world. Thanks for hanging out with us for this explainer, and keep looking at things through that circular lens.